All right, so we're transforming the quadratic graph. And for the first one, we should just be going right 2 and down 4. This is just an x squared graph, so no need to write out a bunch of points because it hasn't been stretched. So the vertex that would be at 0, 0 goes right 2 and down 4. And then I have the shape of the x squared graph memorized. Over 1, up 1 on each side. 2 squared is 4, so over 2, up 4. 3 squared is 9, so over 3, up 9. And I'm just using symmetry to get the rest of the points. So that's it for the first one. And kind of similarly for part B, this graph has gone left 3, up 1. Before I do that, there's an x-axis flexion. So again, I have the negative x squared graph memorized, so I'm just going to move the vertex left 3 and up 1. And then the vertex is going to be over, or the next 2 points are going to be over 1, down 1 from the vertex. And then 2 squared is 4, so over 2, down 4. And then over 3, down 9. And that's our second graph. Third graph is a shift of up 5 units, and every y value is going to get multiplied by negative 1/2. So again, you can write out all of the points like I did in the notes, or you can say 0, 0. Actually, maybe I'll write out the points. So 0, 0 will stay 0, 0 before I shift up 5. Plus or minus 1, when you multiply 1 by negative 1/2, you'll get negative 1/2. Plus or minus 2 squared is normally 4. This time it's going to be negative 2. Plus or minus 3 squared is normally 9. Now it's negative 4.5. And that's all that I'm going to fit, even though I might be able to get more on this grid. Those are the only points that I'm requiring. So 0, 0 goes up 5. Then it's plus or minus 1 and 1/2, and then you go up 5. Or I would just say, like, okay, so from the vertex, I'm going down a half unit. And then again, from the vertex, I'm kind of just using these. From the vertex, I'm going over 2, down 2, instead of over 2, down 4. Over 3, down 4.5. So you should be just above the x-axis there. And that's as far as I'm going to go. That's accurate enough. The alternative is hovering your pencil over each of these and then shifting them up 5 units. But with quadratics, I find that because of the symmetry, it's easier for me to try to just plot the shape as I go, all based off of where the vertex is. For the square root graph, every x value will get every y value will get multiplied by 3, and then we're going to head to the right 2 units. So multiplying by 3, 0, 0 won't change. And then 1, 1 will become 1, 3. 4, 2 will become 4, 6. And 9, 3 will become 9, 9. And then all of those are going to get shifted right 2. So 0, 0 goes right 2. 1, 3 goes right 2. 4, 6 goes right 2. And 9, 9 goes right 2. It's a little off the grid. I'm still going to plot that. So there's that graph. B is one of these special cases. We need to simplify this before we start graphing, or unsimplify this, I should say, before we start graphing. So this graph, all of the x values are going to change signs, so negative x. And then after we do that, we're headed left 2 and down 8. All right, so 0, 0, negative 1, 1, negative 4, 2, negative 9, 3. That's the original points, just multiplying the x by negatives. So 0, 0, and then I go left 2 and down 8. Negative 1, 1, I go left 2 and down 8. Oops, sorry. Plotted that point wrong. Let me start this over. 0, 0, I'm going left 2 and down 8. Negative 1, 1, I go left 2 and down 8. I should be here. And then negative 4, 2. I should go left 2 and down 2, 4, 6, 8. And then negative 9, 3. I should go down 2. I'm sorry, left 2 and down 8. So down 3 and then down another 5. I did say if the points go off the grid, you don't have to graph them. So you could stop after 3 points on this one if you want. And then this graph, every x value will get multiplied or divided by negative 1, and every y value by negative 4. So 0, 0 stays that way. Then we get negative 1, negative 4. 4, 2 becomes negative 4, negative 8. 9, 3 becomes negative 9, negative 12. No shifting to do. So I'm just going to plot these points. And then I can double check my graph at the ends just to make sure what should have happened did. So this graph should be reflected across both the x and the y axis, which it is, and it went through a vertical stretch by a factor of 4. For the absolute value graph, you really shouldn't be thinking about transformations. You should be plotting the vertex, which is at negative 5, negative 3. I know that because of the negative sign, this opens down, and the slope is plus or minus 1 on either side. So I would just, from the vertex, give myself a little slope of 1 and call that one finished. And for this next one, same thing. The vertex from 0, 0 has been moved right 2 and up 1. 1/4 is positive, so this is going to open up. And the 1/4 tells you about the slope. You go up 1 over 4 on both sides. We only need 3 points for an absolute value. Even if the number inside of the absolute value is here, for absolute value, this is still just the slope. I could have written this as 3 times absolute value x minus 7. It's the same thing. So I'm not going to think about dividing every x value by 3. I'm just going to say 0, 0, move it down 7. This graph should open up with a slope of 3 on either side. So absolute value graphs should be the fastest graphs that we have. X cubed. All right, so here I'm dividing every x value by 1/2. And then I'll go up 3. Now you could make this 1/8 x cubed plus 3, in which case you'd multiply every y value by 1/8. And then go up 3. We should get the same graph. So this is one of those. We had something like this in AP Classroom, where one of the questions they had simplified and we had to figure out what it was before they cubed or squared or whatever it was. All right, so for our points, 0, 0 will stay that way. 1, 1, when you, I'm going off of this one. When you divide 1 by 1/2, you get 2, 1. Negative 1, 1 will be negative 2, negative 1. And then 2, 8 will become 4, 8, and negative 4, negative 8. After we do those points, we plot them, we push them up 3 units. So 0, 0 goes up 3. 2, 1 goes up 1, 2, 3. Negative 2, negative 1 goes up 1, 2, 3. 4, 8 goes up 3, so it'll be just off the grid. Negative 4, negative 8 goes up 1, 2, 3, right there. And we should be sketching a smooth curve through those points. Okay. For the next one, B is a special case again. Remember to unsimplify it. Now, the cube root or the x cubed function is an odd function. So if you think about the original graph, if I say flip that across the x-axis, you get this. But if I say flip that across the y-axis, you get the same thing. So a y-axis reflection could also look like an x-axis reflection. But it means all of our points are going to become negative x, y. and then we'll go to the right 2 units. So 0, 0 is still 0, 0. Then we get, instead of 1, 1, we get negative 1, 1. Instead of negative 1, negative 1, we get 1, negative 1. Instead of 2, 8, negative 2, 8, and positive 2, negative 8. So 0, 0 gets shifted to the right 2. And then again, you can plot all these points and shift them, or maybe you know the cube root graph, like over 1, up 1, or the negative cubic graph, excuse me. Over 2, up 8, over 2, down 8 from the center. And that would be our finished graph there. Okay, the negative on the outside for part C means every y value becomes negative or switches signs, the opposite. And then we're going left 2. So that's just the slight difference between B and C. So my points are going to be 0, 0. Well, this is going to look the same, right? I don't want to write all these out. I just got done saying an x-axis reflection looks the same as a y. So I'm just going to sketch the shape of the graph again. So move my 0, 0 to the left 2 units, and then plot that negative x cubed graph from the center, over 1, up 1, right 1, down 1, left 2, up 8, right 2, down 8. So I'm not requiring you to write out all of your points. That's just if that's helpful for you. Cube root graph. Now, I didn't have this in our original parent functions, but the cube root graph is just the inverse of the cubic graph. So if we think about nice points on this one, this is the one that looks like this. So the original points are 0, 0, 1 cube root of 1 is 1, cube root of negative 1 is negative 1, cube root of 8 is 2, cube root of negative 8 is negative 2. Now, for this first graph, we're supposed to divide all of our x values by 2, and then we're going to go up 4. So divide all those x values by 2. You've got 0, 0. You've got 1 half 1, negative 1 half 1. You've got 4, 2, and negative 4, negative 2. And then all of those go up 4. So 0, 0 goes up 4. 1 half 1, 1 half 1 goes up 1, 2, 3, 4. Negative 1 half, this should have been negative 1 half, negative 1, excuse me. Negative 1 half, negative 1 should go up 1, 2, 3, 4 units. 4, 2 goes up 1, 2, 3, 4. And negative 4, negative 2 goes up 4 units as well. So we're going to talk about inverse functions in a couple of days, but this is an inverse of the cubic graph. See how it's just sort of a rotation, or it's a reflection of that graph. Okay. For this one, every x will get divided by negative 1, and every y will get multiplied by 1 half. And then nothing else happens, so I don't think I'm going to write out the points for this. I'm just going to say 0, 0, and then I'm looking at these points and going from there. So I'm going to get negative 1, positive 1 half, and then I'm going to get positive 1, negative 1 half. I'm going to get negative 8 and positive 1, and I'm going to get positive 8, negative 1. This is a vertical shrink and a y-axis reflection to turn the graph around. And part C is going to be every y value multiplied by negative 4, and then we're going to the right 3 units. Okay, so 0, 0 stays that way, and then you go right 3. 1, 1 becomes 1, negative 4, and then it's going to go right 1, 2, 3. Negative 1 is going to become negative 1, positive 4, and then it's going to go right 1, 2, 3. All right, and then the last set of points, we've got positive 8, and it's going to go to negative 8. and then we go right 1, 2, 3, like down here. And then -8 will become +8. And then that's going to go right 1, 2, 3. You need those last couple of points in there to remind you that this should be the shape of a cube root graph, where it kind of opens sideways, I guess we could think of it, instead of letting it shoot up to be an x cubed graph. All right, and this is one based off of these points. I like to write these points out so I can see what I'm working with. So we've got, this is a 10 by 10 grid. So we've got -6, 8, -2, -4, 0, 0, 2, 2, and 8, 0. So for this graph, every y value gets multiplied by -1, and then we go right 4 and up 2. So -6, -8, and then we go right 4 and up 2. And then we get -2, +4, and we go right 4 and up 2. 0, 0 stays that way, and then right 4 and up 2. 2, 2 becomes 2, -2, and then right 4 and up 2. 8, 0 stays that way, and then it goes right 4 and up 2. Connect these points with linear segments and see if it seems reasonable. Our graph was reflected, so this does look like the upside down version here, and then shift it around. Part B, put a star next to that. We've got to unsimplify it first. So we're going to get -xy, and then everything's going to go right 1. Oh, sorry, -x3y, and then everything's going to go right 1 unit. All right, so let me make this smaller so I can get it all on my screen here. Okay, so I think for these I'll write them out. I don't want to keep track of all of that. So +6, 24, +2, -12, 0, 0, -2, 6, -8, 0. All right, the 24 and the 12, I say I don't usually change scales. I am going to change scales for this one. I'll just count by 2s. So these points, 24 will be off the grid a little bit, but not a big deal. So because I don't have enough room to label, I'm just going to say 2 per unit. So 2, 4, 6, 8, etc. Okay, so, and then when I go right 1 unit, I'm not changing my x scale, so this is still 1 per unit. So this is still 1, 2, 3, 4 out to 10. And this goes out to 20. There we go. That's a little bit easier. Okay, so anyway, 6. I'm going out 6 and then up to 24. So that'd be like up here, and then I've got to go right 1 unit. So I'll be at like 7, 24. And then 2, -12. So I'll go down 1, 2, 3, 4, 5, 6 units here because that's -12. And then right 1 unit. 0, 0, right 1 unit. -2, 6, 1, 2, 3, and then go right 1 unit. And -8, 0, and then go right 1 unit. Connect those points with linear segments. Whoop. Now it's hard to tell that this got stretched because I changed my scale, but it did. So I changed the scale. It would be a lot taller, and that'd be more obvious of a stretch. It's also a y-axis reflection. Okay, last one. So here, every x value gets divided by 2 because of that, and every y value gets multiplied by -1/2, and then we're going to go up 3 after that. So I think I better write these down too so I can keep track of them. So -3, -4, -1, +2, 0, 0, 1, -1, 4, 0. All those will go up 3. So -3, -4, and then up 3. 1, 2, and then up 3. 0, 0, up 3. 1, -1, up 3. And 4, 0, up 3. Connect. This graph should be a vertical shrink, which it is, and a horizontal shrink, which it is, and it got shifted up. All right, that's it for today's homework. Come into office hours, please, if you have questions.